Hi, I'm Eric Miller, and today I want to talk about atomic force microscopes with an expert. Sorry, Eric, it looks like you're stuck with me, Eric Miller, but I've got a Hitachi 5100 AFM here, so tell me what you want to know. Okay, well, I have a tricky sample here that I'd like to look at, but before we get started, I need to tell you that I've used an AFM before, and I know they're really useful and all, but I found it very difficult to learn and to use. Well, you also forgot to mention that you're a total klutz and terrible with equipment. Okay, so yeah, there's that too. In that case, the Hitachi AFM5100 is perfect for you. In order to make this the easiest to use AFM in the world, Hitachi has developed an advanced software function called RealTune to make one-click AFM measurements. And RealTune does what exactly? It allows automatic, self-optimizing data acquisition, which gives easier, quicker, and more consistent collection of high-quality AFM images regardless of user skill level. Okay, that's great and all, but as you know, in the AFM there are so many options and things to play with and things to align. If I'm not using this thing every week, I'm going to forget how it works, and then I have to relearn it every single time I use it. Well, the good news on that front is the Hitachi 5100N has an intuitive software interface that provides step-by-step guidance and walks you through everything you'll need in order to collect your data. Wow, okay, so I've got a sample here that's soft and sticky, and this other one here that has a high aspect ratio. What do we need to do to get some topography data? That shouldn't be a problem for the 5100N. We'll start off loading the AFM probe. Oh, I hate this part. The AFM probes, they're so small and fiddly, and then you have to align all those lasers. It's such a pain. Well, we have two great pieces of news on that front. Number one, if you're using the regular AFM probe, the knobs on the 5100N are large and very easy to use. Number two, Hitachi's new self-sensing probes are over twice as big as normal AFM probes and are much easier to handle and don't require alignment. Wow, that was pretty easy. But what would I use that self-sensing detector for? Well, for routine AFM tasks such as topography imaging, which is probably about half of all AFM scans, the Hitachi 5100N offers a breakthrough solution. This self-sensing detector measures the tip-sample interactions by a built-in piezo-resistant sensor. So there is no need for laser and detector alignments anymore. That one thing on its own significantly simplifies the operation of the AFM. Okay, I like that. I like that a lot. But, I mean, if it's really that simple, this must be some dumbed-down AFM for school kids, right? Absolutely not! The 5100N is a full-featured, research-grade AFM that supports imaging in liquid or under temperature control, as well as up to 20 different advanced modes for various local material property measurements, including mechanical, electrical, or magnetic. Wait a minute, on that list there, I saw SIS mode? What the heck is that? That is Sampling Intelligence Scan, a Hitachi proprietary mode that can deliver previously unattainable results for some very tough samples. So what does SIS mode do that's so special? In a normal contact mode scan, the AFM probe is dragged across the sample as it rasters. On a softer, delicate sample, all that lateral shear force can cause some very poor resolution on your scan and sometimes even damage the sample. Yeah, sometimes we get oily samples and it just gunks up the probe. Yeah, that is disastrous for your data. However, in SIS mode, the tip is lifted off the surface in between each pixel measurement, thereby eliminating all that unwanted lateral force. So you're saying it moves the tip to the sample, does the measurement at one pixel location, lifts it back up, moves X or Y to the next pixel, and then measures it again. Exactly. So besides sticky or soft samples, what else would this be good for? SIS mode also works gangbusters on high aspect ratio samples. A normal contact mode scan has a real hard time measuring steep slopes. SIS mode allows more accurate AFM metrology for critical dimension measurements. So just in these few examples, I can see a huge difference this makes in the data I'm now able to collect from samples I thought were a total write-off. Not just are you able to measure these difficult samples, but you're able to do it simply, more repeatably, and with higher resolution than you could do it before. Well, thanks, Eric. The Hitachi 5100N is one cool AFM. You'll give me a good deal on one, right? You'll have to sweet talk the salesman about that, not me. Come on, dude, we're like almost family.